In the last week of May 2026, a commercial satellite passed over a shipyard on the banks of the Yangtze River and photographed something that should not have been there. It was long, roughly 120 meters, according to the analysts, who later measured it pixel by pixel. It was wide, nearly 11 meters across the beam, which put it in a size class above almost every conventional attack submarine on Earth. And it was missing a piece that every submarine, in every navy, on every ocean, has always been built with. It had no sail, no conning tower, no raised structure breaking the line of the hull, just a long, smooth, almost featureless shape, sitting beside a jetty barge at Jiangnan Shipyard in Shanghai, one of the most heavily watched industrial sites in the world. For a few days, almost nobody noticed. Then, a small community of open-source naval analysts, the kind of people who spend their evenings scrolling through satellite feeds looking for exactly this, started asking the same question. What is that, and why does it look like nothing else in the water? By the time the story reached mainstream defense outlets, it already had a nickname: the sailless submarine. And the more people looked at it, the stranger the questions became. Was it a new class of attack submarine? Was it a technology demonstrator? Was it built to hunt other submarines, to hide from satellites, or to do something closer to the seafloor than any of us had considered? China's Navy said nothing. It still hasn't. And that silence is where this story really begins. To understand why a missing sail is such a big deal, you have to understand what a sail is actually for. On almost every submarine ever built, the sail is the tall fin rising from the top of the hull. It is not just decoration. It houses the periscopes, the radio and satellite masts, the snorkel that lets a diesel-electric boat breathe air while submerged. It gives the crew a place to stand when the submarine surfaces in a harbor. On boats designed for the Arctic, a reinforced sail can punch straight up through pack ice. In other words, the sail earns its place. Removing it means solving a long list of engineering problems that most navies have taken one look at and set aside. Western designers have floated concepts for low-profile sails for decades. The U.S. Navy even solicited concepts for an inflatable sail back in 2021, an attempt to get some of the benefits of a smaller silhouette without losing all of the sail's functions. None of it has produced a fielded submarine that does away with the structure entirely. That is the context that made the Jiangnan images so striking. This wasn't a small experimental hull hidden away from view. It was sitting in the open, at full military scale, at China's flagship shipyard, for anyone with access to commercial satellite imagery to photograph. And that had happened once before, at the very same shipyard. Back in 2018, Jiangnan Shipyard launched a much smaller sailless submarine around 45 meters long that most analysts read as exactly what it looked like: a technology demonstrator, a proof of concept, something China was testing quietly to see whether the idea worked at all, with no expectation that it would go straight into frontline service. 8 years later, the same shipyard had apparently answered its own question. And the answer, if the satellite images were accurate, was a full-sized boat nearly 3 times as long as the 2018 demonstrator. The confusion deepened almost immediately because this wasn't the only new submarine to surface that week. At Bohai Shipyard, roughly 1,000 kilometers to the north, a second new vessel had also just launched, this one with a conventional sail. Some analysts believed it was the next generation of China's planned Type 095 attack submarine, a program that had been rumored and tracked for years but never confirmed in hardware. For a brief confusing window, open-source analysts were trying to sort 2 unrelated Chinese submarine programs out of the same news cycle, using nothing but satellite photographs, shadow angles, and hull proportions. Naval News is generally credited as the first outlet to flag the sailless boat specifically, distinguishing it from the Bohai launch and pointing analysts toward Jiangnan. Once the 2 programs were untangled, the sailless boat at Jiangnan became the more unusual story, precisely because so little about it fit existing categories. Start with the shape. Alongside the missing sail, analysts studying the imagery noted an X-form stern, 4 control surfaces arranged in an X pattern instead of the more familiar cross shape most submarines use. X sterns are not new technology in themselves. Sweden's Navy has used them, but pairing an X stern with a hole this size on a vessel this secretive, told analysts, the designers were optimizing hard for something specific: maneuverability, quiet handling at low speed, and possibly operations in shallower water than a typical deep ocean attack submarine would attempt. Then there was the question of propulsion. Later ground-level photographs, taken after the submarine had moved and become visible from land rather than only from orbit, showed something the first satellite images had missed. The boat wasn't entirely sailless after all. It had a small sail, modest in height, nothing like a traditional conning tower, but present. Analysts like H.I. Sutton, writing for Naval News, revised their description accordingly, calling it a small sail design rather than a truly sailless one. That revision mattered, because it reframed the whole story. This wasn't a submarine built around the extreme, almost science fiction idea of no external structure at all. It was a submarine built around minimizing that structure as far as engineers could push it, while keeping just enough of a sail to retain some of its original functions. That is a more conservative, more achievable engineering target. It is also, in some ways, a more concerning one because it suggests the compromise has actually been solved rather than merely attempted. To picture what a smaller sail actually buys an engineer, it helps to think about something far more familiar than a warship. Imagine a cyclist riding into a headwind. A rider hunched low over the handlebars with nothing catching the air cuts through the wind with far less resistance than a rider sitting bolt upright with a backpack on. The backpack isn't heavy enough to slow the bike down through weight alone. It's the shape of it, sticking up into the airflow, that creates drag and turbulence behind the rider. A submarine's sail works the same way underwater. Water is roughly 800 times denser than air, so the turbulence a sail creates isn't a minor inconvenience. It's a significant physical source of noise and drag every time the boat moves. Shrink the obstacle, and you shrink the disturbance it leaves behind. The analogy breaks down once you get into the details, because a submarine's sail also carries masts, periscopes, and communication equipment that a cyclist's backpack does not need to replace, which is exactly why so many navies have looked at this idea and quietly shelved it. But the basic physics, less shape in the flow, less noise in the water, is the same principle driving the design on both. Why go to all this trouble? The short answer is sound. Modern anti-submarine warfare is less about seeing an enemy submarine and more about hearing it. Passive sonar arrays, seabed listening networks, and patrol aircraft dropping sonobuoys are all built to detect the acoustic signature a submarine leaves behind as it moves through water. The hum of machinery, the turbulence of water flowing past hull features, the flow noise generated by anything that breaks up an otherwise smooth surface. A sail, for all its usefulness, is exactly that kind of feature. It disturbs water flow. It creates turbulence. At higher speeds, that turbulence turns into noise, and noise is what gives a submarine away. Shrink the sail, and you shrink one of the loudest single features on the hull. Pair that with an X-stern designed for smoother handling, and according to several outlets covering the story, a pump jet propulsor rather than a traditional propeller, and you get a boat engineered from the outside in to be difficult to hear. Pump jets shroud the blades inside a duct, which reduces cavitation, the process by which propeller blades create and collapse. Tiny bubbles, one of the most distinctive and detectable noise sources a submarine produces. None of these technologies are unique to this one boat. What is unusual is seeing them combined on a hull this large, built this openly, at a moment when China's broader submarine construction has already been accelerating. That acceleration is the part of the story that puts the sailless submarine in its proper scale. According to reporting drawing on Japanese and American analysis, China deployed roughly 10 new submarines between 2021 and 2025 alone, adding tens of thousands of tons of submerged displacement to its fleet in just 4 years. Some assessments project China's submarine force could reach 70 to 80 hulls by the early to mid-2030s. Western navies, by contrast, have struggled in recent years to keep even 1 or 2 submarines simultaneously under construction, hampered by shipyard capacity, workforce shortages, and the sheer cost of nuclear submarine programs. So this isn't really a story about one strange-looking boat. It's a story about what happens when a navy that is already building submarines faster than any of its rivals starts building quieter ones too. And the quieter part connects directly to a specific stretch of ocean that has become one of the most contested pieces of water on the planet, the First Island Chain. The arc of islands running from Japan through Taiwan and the Philippines down toward Indonesia, which for decades has functioned as a kind of underwater fence line for the United States and its allies. Beneath that fence line sits a network of fixed hydrophone arrays and mobile sensors that defense analysts have nicknamed the fish hook, an underwater listening system stretched across the same waters, designed to detect exactly the kind of submarine movement China would need to conduct if it ever wanted to break out into the wider Pacific undetected. Chinese military writing itself has acknowledged the problem this creates. Naval analyst Ryan Martinson, writing for the Center for International Maritime Security, has cited Chinese military journal articles openly stating that the People's Liberation Army Navy cannot currently guarantee submarine stealth within its own near seas, because American undersea surveillance in that region has become, in the words used by those Chinese sources, highly transparent. That is a remarkable admission to find in print from the country building the submarines. It also explains, more clearly than any single blueprint could, why a quieter design would matter so much to Beijing right now. If your own military literature says the water near your coastline has become see-through to the other side's listening network, the logical response isn't to argue with the sensors. It's to build a boat the sensors are less likely to catch. This is not the first time a navy has treated silence as a weapon in its own right. During the Cold War, both the United States and the Soviet Union spent decades and enormous sums chasing exactly this problem, racing to make their submarines quieter than the other side's listening equipment could reliably detect. American Los Angeles-class attack submarines and the Soviet Union's Akula-class boats were both products of that same underlying contest. Not who could carry the biggest weapon, but who could disappear the most completely. What makes the current chapter of that story different is who is now doing the chasing. For most of the last 70 years, the country pushing hardest on acoustic stealth was the United States. A large, quiet, purpose-built Chinese hull launched in the open at a flagship shipyard is a signal that the direct tie-in of that race may be shifting, even if the outcome is still very far from decided. There is a second, more unsettling layer to this story, one that has nothing to do with missiles or torpedoes at all. In March 2026, in testimony before the U.S.-China Economic and Security Review Commission, Jason Haishu described just how fragile Taiwan's connection to the rest of the world's internet actually is. Taiwan depends on roughly 24 undersea fiber optic cables, landing at only 8 stations concentrated along its coast, a geography that creates a small number of extremely valuable choke points. Xu detailed a pattern of Chinese civilian vessels dragging anchors across these cable routes, severing links in a way that is deniable, hard to attribute conclusively to military action, and difficult to prosecute as an act of war. He warned that Chinese repair ships, the same kind of vessel that would legitimately be sent to fix a broken cable, could in theory be used to physically tap into it instead, intercepting data rather than simply restoring service. Perhaps most striking, Xu pointed out that severing just 3 major cable clusters near the Bashi Channel could eliminate as much as 99% of Taiwan's digital bandwidth almost instantly. A quiet, hard-to-detect submarine capable of shallow water operations sits uncomfortably close to that scenario. It doesn't need to fire a weapon to be dangerous in this context. It only needs to reach the right stretch of seabed unnoticed and stay there long enough to matter. This is what makes undersea cable infrastructure such an unusual kind of target. There is no explosion to photograph, no missile launch to detect on radar, no moment that unambiguously crosses the line into open conflict. A severed cable can be blamed on a dragging anchor, a storm, or simple accident, even when the pattern of incidents suggests otherwise. That ambiguity is precisely what makes gray zone activity so difficult to respond to, and precisely why a submarine capable of operating quietly in shallow coastal waters, rather than only in the deep ocean, would be such a valuable tool for a state interested in this kind of pressure. It does not need to declare its intentions. It only needs to be capable and to leave the other side uncertain about whether it has already acted. None of that has been confirmed as the sailless submarine's actual mission. No official Chinese statement has said what this boat is for, and planned silence on the program remains total. What analysts have is imagery, hull proportions, and informed inference built from decades of studying how submarine design choices map onto submarine missions. That inference is not the same thing as proof, and it's worth being honest about where the line sits. Here is what can be stated with reasonable confidence. A large, unusually shaped submarine with a minimized sail, an X-stern and likely pump jet propulsion was photographed by satellite at Jiangnan Shipyard in late May and early June of 2026, and subsequently confirmed from ground level. It is real hardware, not a rendering or a model. Its size and design features are broadly consistent with a deliberate push toward reduced acoustic signature and improved underwater handling. Here is what remains genuinely uncertain. Whether this is an entirely new class of submarine or a specialized variant connected to the long-rumored Type 095 program is still disputed among the analysts tracking it. Some believe the design points toward an improved version of China's existing Type 093 Shang-class attack submarine, with a shrunken conning tower aimed at cutting drag and turbulence. Others argue the technologies involved, including magnetic drive systems and rim-driven propellers, reportedly associated with the Type 095 program, suggest this boat shares deeper design lineage with China's next-generation fleet, rather than simply refining an older one. Its precise mission, whether it is intended primarily as a fast interceptor, a stealth patrol boat, a testbed for future classes, or something built specifically for shallow, contested waters like those around Taiwan, has not been established by any confirmed source. And crucially, analysts are careful to separate design sophistication from proven performance. Building a quieter-looking hull is not the same as demonstrating under real operational conditions, against real multi-static sonar and unmanned detection systems, that the boat is actually as stealthy as its silhouette suggests. Crew training, sensor integration, and real-world acoustic performance all remain unverified. It is also worth remembering that the United States, as of mid-2026, still holds a substantial numerical and experience advantage in operational nuclear submarines, along with decades of accumulated expertise in exactly the kind of quiet-running engineering this new Chinese boat appears to be chasing. Analysts studying the program have been consistent on this point. China's submarine fleet is expanding in both size and sophistication at a pace no other navy is currently matching. But that trajectory is not the same as present-day parity. What the sailless submarine really represents, then, is not a single dramatic leap that instantly rewrites the undersea balance of power. It is a marker, a visible data point in a decade-long pattern of a navy that has gone from a modest coastal force to one building submarines faster than the rest of the world combined, and now, for the first time, openly experimenting with the kind of stealth-focused hull design that used to be considered a distinctly Western specialty. It's worth pausing on just how quickly this entire story unfolded, because the speed itself is part of the message. From the first satellite image at the end of May, to the first outside reporting days later, to ground-level photographs revising the original small sail versus sailless description, to testimony and analysis connecting the design to Taiwan's cable vulnerabilities, the full picture assembled itself in a matter of weeks, almost entirely from open-source material. Nobody needed classified intelligence to piece this together. They needed a commercial satellite pass, a shipyard that couldn't be hidden from orbit, and a community of analysts willing to compare pixels against everything known about submarine design. That is itself a small sign of how transparent the modern world has become, even for programs a Navy would clearly prefer to keep quiet. For the United States and its allies, the response is already beginning to take shape, even if it hasn't been fully articulated in public. Japan, Australia, and South Korea all face direct incentive to expand their own anti-submarine warfare capacity, to grow their underwater sensor grids, and in some cases, to reconsider whether they need nuclear-powered submarines of their own, a threshold none of them has crossed before. American naval planners, meanwhile, are left weighing whether the existing fishhook sensor network, the existing force posture across the first island chain, and existing allied basing arrangements remain adequate against a Chinese fleet that keeps changing shape faster than anyone outside Beijing can fully track. So picture that satellite image again. A long, smooth hull sitting quietly at a jetty on the Yangtze, photographed almost by accident by a commercial satellite, doing exactly what it was built to do. No missing pieces to explain, no official confirmation to lean on, just a shape in the water that shouldn't have looked the way it looked, and a small community of analysts piecing together, frame by frame, what that shape might mean for the quietest, least visible part of modern warfare. The submarine still doesn't have a confirmed name. China's Navy still hasn't said a word about it, and somewhere off the coast of Shanghai, whatever it becomes next is almost certainly already being decided, far below the surface where nobody outside that shipyard can see it happen. If you had to guess what this boat is actually built to do, based on everything laid out here, what would you guess, and why?